Okay, let's begin. Hello, everyone, and thank you for joining this stream on sustainable maritime operations. My name is Afshin Mansouri, and I'm chairing this session. I'm a professor of operations and supply chain management at Brunel University, London, and also principal investigator of the EU-funded project PortForward at Brunel, and a work package leader for one of the work packages of the project on sustainable operations and green scheduling. Today, we are going to have three esteemed speakers from the three EU-funded projects as part of the Port of the Future network, which is a European funded network of 4 projects started from 2018 with a total funding from the European Commission of in excess of 16 million euros. One of the projects has already ended, Talks the Future, and today you are going to hear about the visions of the 3 projects and their vision in making operations research and operations research management science methodology, data science, in making the Port of the Future greener, smarter, and more sustainable ecosystems. The first presenter will be Cihan Butun, our colleague at Brunel University PortForward team, who is going to present a talk on the Green Yard scheduling. Title is The Green Yard Scheduler. The second talk is by Irene Schoss, co-authored with Stefano Persi on multimodal freight transport planning and prediction, which is part of the COREALIS project. And the third talk from the PIXEL project by Erwan Simon is titled Supply Chain Modeling as a Transversal Tool, Port Activity Scenario Model. Before starting our talks, I'm going to give a few housekeeping notes. During the talks, if you have any questions, please type them in the question and answer box that you can see in your Zoom ribbon. And I will summarize them and ask at the end of each talk. You can also share your view about any question by giving it a thumb up, and the question that gets the highest thumb up will go automatically to the top. So I will notice it and try to start by asking questions which have more favorite views. And at the end of the 3 talks, if there is any time left, we can continue our discussions and answer any remaining questions. Please note that the whole session will be recorded, including the comments that are posted. And the copy of the recorded video will be made available after some editing by the OR Society to the participants and to the wider public. Everybody who can access the conference website can see and view the recording of the call. And I would like to wish you all the best and enjoy the session by handing over now to the first speaker, Cihan from Brunel University. I stop sharing my screen so that Cihan can share his. Cihan, over to you.
Thank you, Afshin, for opening our stream. And as you have summarized, I will introduce the Green Yard Scheduler, which is essentially a decision support system being designed for more efficient and sustainable container terminal operations. This work that we undertake here in Brunel University is part of a bigger project that is called PortForward, as you have mentioned. And I will begin my talk with a brief overview of PortForward, its participants, and its main principles. The rest is dedicated to some highlights related to the design, development and experimentation of the Green Yacht Scheduler and its interactive optimization modules. I refrained from using field-specific jargon and detailed mathematical formulas as much as possible and focused on the most fundamental concepts supported with visuals. So let's start with PortForward. PortForward is a European Union funded project that aims for smarter, greener, and more interconnected ports. It covers a period of 42 months between 2018 and 2021. It is within the Ports of the Future initiative of the EU. And as I said in the beginning, the Green Yacht Scheduler is just one of the work packages of this project. There are other innovative tools that contribute to the PortForward dashboard, ranging from IoT solutions to augmented reality and virtual portal. There are 13 project partners from different parts of Europe, as you see on the map here. And these also include use case ports from Italy, Spain, Germany, and Norway. Before going into more details, let me clarify what we mean by green scheduling. Essentially, it involves incorporating environmental concerns into the process of scheduling as explicit objectives. The goal is to find a compromise between the conventional efficiency-oriented objectives, such as completion time or lateness, and sustainability-oriented ones, such as CO2 emissions. Green Yacht Scheduler is a decision support system designed around these principles and for the use of container terminals. It is currently being developed in collaboration with Vigo Container Terminal, but our ultimate aim is to develop it as a standalone program which can be used by other container terminals as well. In consultation with Vigo port and terminal operators, we identified 4 key objectives for the scheduler. First, we want to find the bottlenecks of the current operations and increase the productivity. At the same time, we focus on reducing the carbon footprint of the terminal. These can only be achieved by the harmonious coordination of the terminal activities and integration of the scheduler with the operating system of the terminal. In the beginning of the project, our team has implemented a problem scoping procedure to identify and select key optimization problems. And after considering more than 10 such problems, we have decided to include 3 modules to work interactively. These are pre-marshalling, container positioning, and yard crane scheduling. I will explain the underlying optimization problems in the next slide. This architectural diagram you see summarizes the data exchange between the 2 systems. The scheduler pulls the information on the existing containers in the container yard and the containers that have arrived during the planning period. All the new arrivals need to be allocated an empty slot in the container yard, and each resulting container movement is a job for the yard crane scheduling module in terms of scheduling. The location allocations are determined by the pre-marshalling or positioning modules depending on the nature of the task. And the container movement jobs are scheduled to available yard cranes with the yard crane scheduling module. The output is the locations of the new containers and the yard equipment job plan. As I touched upon in the previous slide, Three optimization problems make up the basis for these three interactive modules. So let's go over them very briefly. Pre-marshalling as a term refers to the reordering existing containers in a specific area of the yard according to their estimated retrieval time to eliminate the need for relocations, which are also called reshuffles, when the terminal is busy. So this operation is usually done in off-peak hours in the terminal to save on the yard equipment's time. Container positioning problem is to allocate a slot position to each container that arrives at the terminal during a specific planning period. There are some practical limitations, such as separate designated areas for export and import containers, which we formulated as constraints in our model. Finally, yard crane scheduling is to assign the jobs to the available yard cranes at the planning period. Again, there are use case specific limitations which we considered in the module. Now we come to the practical application of green scheduling to our work. Leitat Technological Center, one of our project partners, have done an initial sustainability assessment of the current terminal operations. Based on the results of that report, we have identified one performance and one sustainability-oriented objective for each problem. Our focus is to reduce the energy consumption of the yard equipment on one hand, and to increase the efficiency on the other. For example, the performance-oriented objective of the container positioning problem is to reduce or minimize the number of reshuffles or relocations, and the sustainability-oriented objective is to minimize the energy consumption of the trucks that move the containers within the yard. Similar and potentially conflicting objectives are defined for the two other problems as well. We have also run some computational experiments to assess the validity of the underlying mathematical models and our algorithms in development, also to analyze the impact of green scheduling on the terminal operations. I will share some of the insights for each problem. In pre-marshalling, we observed that the module can find such a sequence of container movements that minimizes the energy consumption without compromising on efficiency. In the experiment instances, for example, we recorded 4 to 6% energy reduction compared to the case where energy minimization objective was disregarded. Our experiments show that the objectives of the container positioning problem are clearly conflicting with each other. This means that the decision maker can save on energy consumption, but in the expense of greater container reshuffles or relocations. Here we recorded 13 to 34% saving. A similar picture is revealed for the yard crane scheduling, where the energy savings are achieved in expense of greater delays. We are also developing a graphical user interface for the scheduler that enables the user to run the modules, visualize the results, and execute the selected decisions. Here I wanted to show you a few screenshots of the main window and some of the modules. The user interface is still under development, so what you see here is rather basic. but I think it gives an idea about how the user can interact with the scheduler. One of the features of the graphical user interface is to display the Pareto front. On this plot, the terminal operator can see the trade-off between different decision alternatives. In this screenshot, for example, you see the Pareto frontier of a container positioning problem instance for different number of reshuffles and energy consumption. And when the user interface is finalized, the user will be able to see the Pareto front, check the objective values of solutions, and decide which one to implement. In the last slide, I want to summarize the prospects of the yard scheduler. Our short-term goal is to make the solver ready with the algorithmic structure and user interface for beta testing. And if all goes well, we will perform the offline and then the live tests in Vigo next summer and complete the user version by the end of project deadline. As I mentioned in the beginning, the wider perspective is to bring the scheduler to a functional level for the practical use of other small, medium, or even large size container terminals. So that brings me to the end of my talk. I would like to again thank you for joining this stream and listening to our presentations. And we will be pleased to have your questions or comments. You can also reach us through the emails shown here.
Thank you very much, Cihan. We have 2 or 3 minutes for question and answer, and we have one question here. The gut feeling would be that the energy consumption should be well correlated with the number of movements and reshuffling, but you implied that 2 objectives are trading off here. Can you explain that a bit in more detail?
Yes, so the reshuffling refers to the case where the location where you put the containers, if you put the container in a location where you will have to move the container again in the future, that is called a reshuffle. So it might be such a case that the closest location where the truck can bring the container could be crowded, which means more reshuffles. Whereas remoter parts of the container yard might be emptier, which means less reshuffles. There won't be any need to relocate any of the containers, but that would mean a longer distance traveled by the truck. So that would cause a higher energy consumption. There is that kind of conflict that we observed in the container positioning problem. And a similar logic goes for the yard crane scheduling.
Thank you very much, Cihan. Just a follow-up comment on that point. We are experimenting actually the theoretical conflict between the 2 objectives, and we are finding contradictory examples that show that the 2 objectives cannot be optimized at the same time all the time. Maybe in most cases they can, but there are exceptions like the one that Cihan explained. You need to make a trade-off.
Yes.
The second question is, what size of problems can you currently handle with the algorithms developed, and how quickly can solutions be presented to decision makers?
Our algorithms are still in development, so we had some progress with the pre-marshalling problem, for example, and I can give you some examples from that module. In that module, we can solve problems up to the, I can express this as the slot numbers, so up to the container base to the size of 24. So the module can solve a problem size with 24 containers which need to be reordered. We have room for improvements, but we can solve problems 24 or less in reasonably short computational time. And for the other modules, we are still developing algorithms for the container positioning. We are experimenting with problem sizes up to 50, 100, and 200 containers to be allocated a location. And for the yard scheduling module, we are experimenting a size of up to 50 container jobs.
Okay, thank you very much. One last question before we move on to the next presentation. Can you say a few words about the model? Is it Monte Carlo?
No, it is actually for different modules. We have developed different mathematical models, and for most of them we had a mixed integer linear programming model. For the yard scheduling module, we had a nonlinear model developed first, but we have linearized that model to be tested in the commercial solvers.
Okay, thank you very much, Jihan. It's very inciting. It was very insightful talk and interesting questions and answers. Thank you very much. We can give you a virtual clap at this stage, and now move over to the second presentation by Irene.
Thank you. I will start sharing my screen. Okay, so good afternoon, everyone. Let me first introduce myself. I am Irene Schos from Mosaic Factor. Mosaic Factor is a startup based in Barcelona, and what we do is big data for mobility and logistics problems. I am an industrial engineer, and I'm working here as a data analyst, and I'm currently working in different H2020 projects, and one of them is COREALIS. Today I'm gonna talk about what we are currently doing in COREALIS, which is a solution for multimodal freight transport planning and prediction. But first of all, I will tell you a bit about this project. So COREALIS is an H2020 project that proposes an innovative framework supported by disruptive technologies, including IoT, data analytics, traffic management, and 5G networks for cargo ports to handle future challenges as the traffic efficiency and sustainability. The project has a duration of 3 years. It will end in April 2021, and it received a funding of around 5 million. In the consortium, we have different key players from the port ecosystem, and all the COREALIS innovations will be tested in different ports, in which we call the living labs. And we have the Port of Antwerp, Port of Valencia, Port of Piraeus, Port of Jamina-Kotka, and the Port of Livorno. In our case, our solution will be tested in the Port of Antwerp, which is the second largest point in Europe and one of Belgium's biggest economic driver. The challenges that is facing Port of Antwerp, as well as many other European ports, are in terms of making the mobility more efficient, to achieve a sustainable growth, also dealing with data sharing to increase the operational management, and to go into the transition of green ports and ports connected to cities. So, well, when we were designing this proposal, while we were talking with the Port of Antwerp, we wanted to design a solution that provided an optimization of the operations of the port. So we designed the cargo flow optimizer with the objective of increasing the percentage of utilization of sustainable transport modes, such as rail and inland waterways, after the container arrives to the Port of Antwerp. So by using and analyzing real-time data from the port, the cargo flow optimizer tools will offer shippers the optimum route and will predict the container's destination. So, as I said, to accomplish these objectives, finally we decided to develop two different tools. One is the multimodal inland planner, and the other one is the cargo flow prediction, which they are two different tools that they can work separately, but both of them have the objective of optimizing the port operations. So first of all, I will explain what's the multimodal inland planner. The main goal of the multimodal inland planner is to give a complete overview of the most efficient connections between the port and its hinterland by rail, barge, and truck. So it calculates the optimal door-to-door container routes between the Port of Antwerp and another port terminal or any destination in Europe. And this optimization of the routes is in terms of distance, the estimated duration of the trip, price, and the CO2 emissions. So, well, this is a beta version of the tool. And here the user can define the shipment needs and can enter the destination also with the container characteristics and the desired date of departure. And afterwards, the tool will compare the available routes from transport operators that operate in the Port of Antwerp and will present the most relevant ones, optimizing the costs, the routing, and the ecological footprint. This is also very useful for shippers because up to now they didn't have a solution where, I don't know, like we have Google Maps when we want to see where to go. They usually had this information in different databases, in like also calling and so on. And this is a way to have all this information together and makes it easier to provide optimized routes in terms of, as I said, emissions, price, and duration of the trip. Then we have the second tool, which is the cargo flow prediction. In the case of Port of Antwerp, the road transport is responsible for more than half of all the freight traffic operations. This means that most of the operations go by truck. And in order to achieve this vision of future ports and green ports and to improve the management of the logistic resources of the ports, it is very important to understand how the container traffic flows work. So this means that knowing the frequencies and the volumes of the container arrivals and departures for each of the transportation modes is essential. So the main goal of this tool is to predict the multiple cargo flow using historical information and the daily traffic of the containers from the different transport modes between the port and the European hinterland. This task has a high complexity as the fluctuations in the economic activity are quite high, but also the nature of the logistics sectors where the quality of the data is not the best or the one we could wish. So, well, what we did with the cargo data we had from the Port of Antwerp and the daily traffic data, we developed several models in order to test the prediction and to capture the performance of the boundaries. We tested some different models like SARIMAX, and like we tried some classical models, but also with artificial intelligence. And then the best option we found is to follow an artificial intelligence approach with artificial neural networks, specifically with the multi-layer perceptron. So what we did was an exploration and data analysis of and time series analysis of the data we had. We tested these different models and evaluated them. And now what we have is with this multi-layer perceptron model, we have the daily prediction of the containers and their destination, and also which mode of transport, and up to 1 week. Like it's daily prediction, and we predict the next 7 days. Well, that was everything. I just explained like the two tools in like quite high level, but if you have any questions, I'm here to answer, and also maybe my colleague Emilio can also join or answer them on the chat if they are more technical.
Thank you very much, Irene. Very timely presentation, very concise and informative. There is one question already from the audience. I start off by this. What forecasting models are you using?
Yeah, well, we tried different ones. Like the one we had the best performance was the multi-layer perceptron with, let me check, I cannot remember now. Yeah, yeah, the multi-layer perceptron with one hidden layer.
Okay, thank you very much. The next question is the model planner available online?
Yeah, the idea is that it's available online. Now it's online, but you need a user and a password that only, well, people from COREALIS project can use it. But the idea is that we can publish it online after the end of the project, or when we have like a more robust version.
Okay, thank you. And the last question, what features are you using for the predictor? Is it mainly time series based or also dynamic features?
Well, it's time series, but also with the dynamic traffic, with the real time traffic. This prediction is updated every day. But one of the things, well, we analyzed and so on was if it really made sense to give a really detailed prediction, I don't know, like hourly prediction, and for the characteristics of the ports, the prediction that it made more sense was a daily prediction. So it's not like very, very dynamic.
Okay, thank you very much, Irene, for your responses. And like in previous talk, we can only give you an electronic round of applause. And now let's move on to the last, but by no means least, presentation by Simon from CATIE. Sorry, Erwan Simon from CATIE.
Thank you very much. I just start the sharing of the screen. Do you have the screen sharing?
Yes, the screen is shared.
On full screen. Okay, thank you. So another European project, but another context. Here we don't have fancy mathematics stuff. We don't have even big data, sadly. But we think we can have something that can be interesting in some context. I would like to expose or proposition how supply chain modeling can be used as a transversal tool to address several complex tasks. So normally the port activity scenario model. I will start by presenting the context because it will be the key point to understand the value of the proposition. Then I would explain our approach, why we do that and how we do it. And to give a little bit more concrete example, some use case, and we will finish with some perspective. So let's jump into it, the context. Oh, it seems you don't have. Okay, should be better, I guess. Okay, okay, sorry for that. So context. Here we are addressing the small ports. It means that they need a tool first to gather all the available data and found a way to extract value from it. Here we don't have a huge team of IT people and data science. I will not say they have nothing, but not enough. They have huge constraint because they have huge variability. First, about their data, you can have data come from a sponsor, from the port information systems. There's a huge difference for this kind of data. You have difference in the type of data. There is data that you can rely on. Some we don't know. Some other data we know that you cannot rely on it. Some are always available. Some will be available next week for the current week. Some ports or for some part of the terminal of the ports, they want something really precise, but sometimes they don't want something precise. They want something really simple. And if you want to provide a tool that can address a lot of different ports, you will have an issue because you will have different kind of goods, and managing container is pretty different than managing passenger or cargo, bulk cargo. And here we have to handle all of this, and the process are different. In some ports, they are the owner of every process and resource, and sometimes they own nothing. And finally, last but not the least, you have significant evolution of the process and machine. So you cannot so much exploit historical data to forecast future. So as you can see, it's not the sweetest spot for machine learning or uncertainty management. But anyway, we have to address this context. So we need to provide a tool that can adapt to the port context. So it means the tool should be able to handle data heterogeneity, multiple use for the user. They want to make assessment, monitoring, forecast, explore their process. And they can have, we should tip of use, focus on energy, on pollutant emission, efficiency in the process, and we have to scale our output precision to the input or the user needs. So there are some components of the PIXEL platform. To put it briefly, you can picture that like a tree. So from the bottom to the top, you've got the roots that try to extract data from the environment, the trunk that manage the flux of the data in the whole system, the structure, and you've got the leaf. That's where we are here in the past model. We take the raw data and try to add a little bit of information on it, something more elaborate, until we can produce fruits that will be the end user takeaway. So now we've got the big picture. What is our approach with this supply chain modeling? If we try to explain really simply how does it work with a schematic linear view from the data on the left that come from sensor or any source, we will do a first step that is build the port activity scenario. Basically, from all this information that we have, we try to build a scenario that say what happened, when does it happen, and how does it happen. So it will be a three structure of the activity in the port. I will manage this boat on this dock with this machine, and after I will do that. That's what happened. And after, we will make calculation about the outcome. Okay, if this happened, what does it mean? What are the consequences? So now we will have a closer look on the port activity scenario builder. So here again, it's a really simplest view. I've got for example, with my vessel call, I've got the schedule of the boat. I have to unload this one, load this one with this content, this cargo. I've got information about what we call the supply chain that say an oriented graph of theoretical operation for this kind of content, for this cargo type on this dock. I will use a crane, and after that, when it is finished, it will trigger this operation that will occur for 20 minutes, and this one will occur until this other is finished, this kind of operation. And this involves machine, area, road that have a specification. This is the throughput of this machine, this kind of information. Will all this information and other, but we keep it shortly today, you obtain the path, the port activity scenario that you can see nearly as a Gantt. What happened, when, how. So it's quite simple, but there is interesting things in that to address our issue that is huge need for flexibility to adapt to the data and needs of the user. So here we've got flexibility. We can adapt the modelized parameters from the input. Are we considering a boat to load or unload, or trucks to load and unload, or both? Depending on the scope of your input, you will have the equivalent scope for your output. And depending on the input you provide, if you provide a live stream of data from sensor, you are actually monitoring what's occurring into the port. If you use historical consolidated data, you are actually doing assessment of what's happened really. And you can even elaborate some crazy scenario. What's happened if I change all my crane to electric stuff? Okay, let's explore that and compare scenario. If I do this modification, what is the difference on the result? You can do that. Another point is also a plasticity to adapt to what is available as data. If you have only a minimalist setup, you have only vessel call, so expected arrival and departure time. You describe all your process as one big step, a long step, without any detail. Even for the machine, you merge every machine and you say, okay, this is my virtual big machine that merge every machine specificity. On the other hand, if you want, you can go on really, really detailed description of your activity. So you will provide more precise data about the exact amount of materials that have to be handled, the exact arrival time. You will describe every step of your process and every dependency of your process to adapt to the real solution, to go with a more precise description of what really happened. You can add, you can even explode a machine into its component because you want to track each subcomponent of the machine, of big machine complex. You can add data from, let's say, a weather station. If it's raining, we know that you will not, during this time, handle cereals, for example. So you can choose as you want, or with your constraint as a final user, with the trade-off between precision and simplicity. So that's, we think it's valuable for, again, the small sport context. So now let's have a look with to the outcome module. We've got the path that tell us, okay, considering this bunch of hypotheses, this is what happened. What are the consequences? You will use some module, the outcome module, that are, each one is really dedicated to one little calculus, as simple as possible. Each module will use the path as an input and put it back as an output. A module can add information into the path or cannot, and just, for example, make data transformation. I will filter some kind of category of activity. I will make a zoom, and I will put this data back to the information hubs. And you can also have a preset sequence, ordered sequence of a module. Each module makes a little step in the progress to transform the raw data into information and, if possible, into actionable knowledge. So it seems certainly a little bit theoretical here. So let's jump to some example. I hope it will help to explain why we think it's valuable to start from something really basic, supply chain modeling, to address complex tasks. We'll start with energy. So here we've got the path builder that creates the path. So the path, if you remember, I can cover 1 hour or 1 year of data. Anyway, every activity that's happened, I've got information about. It's related to which ship, which cargo, and I've got information. It starts then, it ends at this time, so I've got duration, and I know which are the machine related during this operation. On the machine specification, you can have energy consumption. I know this machine, this crane, use electricity and this amount for 1 hour. You can go deeper, more detailed, but we keep it simple. So we will be able to add a new information to the path for each activity, the energy that is consumed for each resource. Okay, again, you can sum it, you can do all the calculations that you want, but at the end, you can extract here a time series about your cumulative energy consumption or the sum of every electrical consumption for 1 hour, for example. And this can address complex tasks. For example, if you are a port operator, you really want to avoid your annual energy peak consumption. So if you provide as an input the scenario of your next week boats, at the end you will have projection of your consumption of electricity. If you see you reach some threshold, your annual peak, you can avoid it. You will delay some shipment, change some things in the process because there is too much cost to reach this annual peak. Something nice is if you imagine a solution, an alternative solution, you can run it as a past model again and see the difference. You can also use external data. If you have photovoltaic panels, you have a time series about your electrical production. So you can run a model on it to forecast next week. So now we've got 2 time series. We can make balance, automatic calculation about the balance between those 2, production and consumption. And now you can alert the grid, electrical grid manager, when this amount, or we put back into the grid this amount tomorrow. Again, this is something that is pretty interesting for a small sport that starts from nothing. So even if there is uncertainty, you allow to start to get value from the data. Let's jump into environmental consideration. So again, remember, after the pass, you can have unlimited sequence of module. You can even do some loop on it. It's again an oriented graph. So we see that we can have energy consumption. If you know that this machine have consumed this kind of fossil fuel, we can use emission factors to know the amount of pollutants that you have produced. So it can be default emission factors value or specific to your machine. Again, we adapt on what you have as a data. So you know what are the pollutants related to, let's say, this terminal during this week or for this boat. You can even make some data transformation on this time series about your production of pollutant, put it back into the information hubs where it is available for other models that will use that as an input to evaluate risk for the city. So I hope you see our point how we try to use simple things to address complex tasks. Now let's talk about perspective. First of all, the work is still in progress. We are still doing some developments. There are some fancy options that are not running as properly as we would like. And we also are deploying into 4 ports that are acting as test case, scale 1. And we want that everything runs smoothly. After that, PIXEL is an open platform, open code. So we would like that every small port that needs something can use this tool as easily as possible and build a community about how good practice, how to set up this and this, because at the end, a few years after, we are not here. So we need simplicity for community to adopt the tool. Another perspective will be to extend the pass builder scope. Currently, we only manage the sea gate, so boats that are loaded and unloaded, but we would like to extend it to warehouse stock and interland gates, because again, if you know how to handle, to model how to unload or load a ship, it's not so different to load or unload a truck. There is many same elements here that you can use. Finally, we try to have the module as simple as possible to allow community to add new module to address new tasks. In perfect world, we would like to have some kind of market, module market, like in your Android or any system. Users can add module freely, or we can pay on it. But it's the same idea that the community owns the tool to extend what you can do with it. So thank you for your attention. It was some spotlight on one module of the PIXEL platform, the port activity scenario modeling. If you want more information, please visit our website. There's a newsletter. You can follow us on Twitter or email the corresponding people. Thank you very much.
Thank you very much, Erwan, for the great presentation and timely delivery. We have now some minutes for question and answer. And as I was informed, because the next session on this stream will start with some gap, we may still use this chat room to continue conversation. In case there are questions to Erwan or other speakers of the session, feel free to post your questions in the question and answer box, and we will try to address them now. Alternatively, if you have any questions that you want to ask later, you have contact details of all speakers, feel free to get in touch via email, or as Erwan mentioned, by visiting the 3 projects web pages and contact the corresponding people regarding these projects. There is no question as of yet, so I will wait for a few more minutes and then close this session. I hope you all have enjoyed this stream, which featured the 3 sister projects of the Port of the Future Network, a major European Commission's investment in making improvements in the future port by using a wide range of techniques and methodologies, including operations research, data analytics, simulation, and soft OR in general. Okay. Well, the 3 projects, there is a question, general question about the way the 3 projects are connected. As I said, these 3 projects, PortForward, COREALIS, and PIXEL, are part of a network named the Port of the Future, an investment of almost 16 million euros by the European Commission. And each of these projects work with a set of stakeholders and technology partners and research organizations to address different aspects of port operations from different perspectives. And through this network, we communicate with one another. We have occasional joint and shared delivery like this one that we have today. We will have some more sessions in future. Okay. Now you can see me. Okay, we have a series of dissemination activities like this one that we have today as part of the OR Society annual conference. And there are some other activities, and if you are interested to know about future activities, stay connected and follow us on Twitter and LinkedIn. All 3 projects are active on social media. They all have Twitter accounts and LinkedIn accounts, and you can follow their updates in there. Okay, now there is one question here for Erwan, if Erwan is still here. Integration is always the key in supply chains. Could you tell me a little more about how these projects will tackle the challenges? Okay, I think it's a general question for all, but I start with Erwan. Erwan, if you have any comment on this, please feel free to share, or otherwise, if other speakers have something to say, please do so.
The point is, I so deeply agree on this statement that everything is said. It's such key point, such massive question, such important issues that it's not easy to say, oh, we resolve this issue by doing that. No, actually, it's the biggest trouble. So in our case, so for the port activity scenario modeling, we rely on the PIXEL platform that have several ways to acquire data. I will not even be able to go too deeply in how does it work, but basically you've got a firmware that it's called Fireware that was developed initially to provide a big technical solution for smart cities. We rely on that to be able to connect to a huge variety of interface, from raw sensor to API database. And for each of the 4 ports, we develop a collection of connectors to get the data. So we try to propose with the platform a set of template for connect to all the data flux that you have. And if we are not able to provide the ready for your case, the one you can deploy easily without doing nothing, we try to provide all the information to be able to build and do the tricky stuff to connect to your context of data provider. I hope this answers the question, at least for PIXEL.
Okay, thank you very much. Irene, do you have anything to say about your approach in integration in the COREALIS project?
Yeah, we also think that integration is very important, and not also integration, but also collaboration between the different port stakeholders. And well, most of the COREALIS innovations are achieved thanks to collaboration between different stakeholders. For example, by data sharing, you can achieve, well, for example, the tools we explained, and also the other innovations that are being developed in COREALIS. But yeah, as I said, like for integration, first you need to collab, or that all the port stakeholders, that they don't see each other as competitors. They try to collaborate and try to integrate their services to provide better solutions that make the ports more sustainable and can, yeah, well, provide innovations for the ports.
Okay, thank you very much. And Jihan, do you want to comment on the way we actually address integration in the PortForward project?
Yeah, I mean, we have, as I said, we are not an isolated work package in this project. There are other ongoing innovative developments with other use case ports. And one of the objectives of the project as a whole is to have integration and collaboration between different use cases and different innovative tools. So, for example, one of the things which is critical for the supply chain is to have the use of technology in better monitoring, which is critical, monitoring of the flow of cargo, which is a critical point for the efficiency of the supply chain. For example, we plan to have such a collaboration with one of our project partners, IMEC from Belgium, for the use of Internet of Things on movement vehicles, which are basically trucks that bring containers from the shippers and to the port. And monitoring, having a chance to monitor these trucks and having more collaboration and communication with the shippers is a very helpful thing for our module as well, because that will make our lives quite easier when we actually have the chance to run the module with more information and more precise data. So that's actually quite a crucial point to have this kind of projects having integration with other supply chain partners, not just the terminal operator or port authority. So that's a very valid point.
Thank you very much. A follow-up comment on this in the PortForward project. One of the considerations that we've had from the beginning, in our work package at least, in the development of the Greenyard scheduler, was its ability to integrate with the existing systems at port. And our port partner, the Port of Vigo, like all other ports, use their own terminal operating systems. And we started actually developing the system in such a way that can communicate and interact with the terminal operating system. We didn't want to develop a tool that is another tool in parallel with the existing system, because all the communication, all the instructions, all the data in the port is handled through an existing system. So our aim from the beginning was to develop the system, our tool, our modules in a way that can communicate and interact with terminal operating system, pull relevant data from TOS, it's called TOS for short, get data, pull data, relevant data at required interval from TOS, do the processing and send back the outcome to the TOS for implementation through the existing procedures. And we have other mechanisms and other plan to integrate the system at a wider extent, because our idea is for the system to be able to be used by literally all ports. And our vision is to put it on a cloud-based system. The PortForward decision support system will be a cloud-based decision support system. And the users can connect to the cloud-based DSS for usage in other ports in other locations. So this is a right point, a big challenge, but we are working on it, and we are hopeful to be able to address it, given the very good atmosphere in the projects that we have. We have a very collaborative work environment with all other partners, and hopefully we'll be able to make a good progress on that side. I hope these answers have addressed your question, and because there is no more questions here, I am going to close the session, and thank you everyone for their participation in this session, and thank you for our speakers and the session organizers for a very insightful and stimulating session with a good participation from the audience. Stay tuned for the follow-up updates from the conference regarding the video recording of the session. And if you had any follow-up comments, feel free to stay in touch. Enjoy the rest of your conference. Have a good day, and hope to see you sometimes in the near future in person. Thank you all, and bye.
Thank you. Bye.
Thank you. Goodbye.
Thank you.